This is the blockchain speaking.
So, hey, Martin, we're going to have a little bit of a technical discussion around the new decentralized end-to-end encrypted instant messenger on Solana called Solarium. Martin and I have been building this. We're just going to go through a little bit of a chat about how it works. And Martin, you're going to pretend you don't know as much about it as you do for the purpose of this chat. Yeah, Martin, so you're going to go through going to go through an onboarding process.
Yeah, hi Dan.
Hey, so yeah, I'll hand it over to you, and then we can kind of step through each thing that's happening, each step, and discuss what's actually happening on the chain.
Cool. So I helped develop it, but this is the first time I'm actually on the production instance of Solarium, which everyone should be able to use freely. I'm only sharing my window, so you will not see my wallet interaction for this, but this is a brand new instance. Okay, I'm going through the onboarding flow. So I have to first create a completely new wallet account.
Yeah, we only support Solid at the moment, but we're going to be supporting all the usual Solana wallets very shortly. And at the moment, we're also on DevNet, not on mainnet, which has the nice feature that we can kind of do airdrops in the background. So it will also, as well as creating this wallet, in the next step, it'll airdrop a few DevNet sols for you to get you started.
That's convenient. Okay, the next is creating an identity, which triggers a transaction to create a DID on chain.
That's right. And a DID, just for people who aren't familiar with the term, is a decentralized identity. This is a standard that's used across the identity space, really. And we have an implementation on Solana, which allows us basically to attach multiple keys to a single identity. And this is important because it allows you, for example, to use different devices, but still have access to the same have access to the same messages and the same address books and so on. Even if you're using completely different Solana wallets, you still have access to the same information. It's all tied up in this decentralized identity. So that bit's done.
So quick question between, why did you decide on using DID as an abstraction for key materials?
The main reason was because it's a standard. It's an emerging standard, but definitely a standard. And I felt like it was a good abstraction and one that already existed on Solana. We have the Sol DID program running on all chains, and that allowed me to kind of both piggyback on top of that for key abstraction, as well as making sure that I stuck to standards as much as possible.
So are you thinking about also supporting DID methods that are anchored on chains other than Solarium?
Solana, yeah. Actually, that's a good point. So DIDs are also portable. So theoretically, the actual identities don't need to live on Solana themselves. That would take a little bit more complexity, especially around identifying ownership of keys when it comes to signing or checking signatures of transactions on chain. But it's certainly possible, yeah.
Okay, let me finish the flow. I think the persistence is baked into Solana, and so that dependency definitely exists and is built into the product. Okay, I add the browser key to my DID, which also triggered a transaction.
Exactly. So at that point, what you're doing is you're registering one device onto your newly created identity. In this case, that device is this browser.
Okay, now it says join the public lobby. It triggers yet another transaction that I approve.
That's right. Yeah, we have a public lobby, which is one that it's the same as every other channel, except that the authority to invite is open. So you're effectively inviting yourself when you join, and that's what the transaction is. And this maybe is a good point. Well, let's click let's go so we can see the UI in total. Here we are.
Cool. And I can already see the messages that you generated in the past.
Exactly. So what you did in the last transaction was you invited yourself to a channel. And what that means in Solarium is you, normally an inviter would invite you, and the inviter decrypts the key for that channel and then re-encrypts it for the invitee. In this case, you're both the inviter and the invitee because you have access to the key of the inviter. But what that essentially means is you now have an account, a Solana account on chain, linked both to your identity and to the channel, the lobby channel. And what that account contains is the key for that lobby channel encrypted with all of the keys that you have associated with your identity. That's what it means to be a member of a channel on Solarium.
So the lobby is a special account where the key to access this lobby is available to everyone. And I
yes, but in fact,
myself.
That's right. On chain, there's nothing special about the lobby. On chain, it's just a channel like any other. Off chain, the private key for the lobby is encoded in the source code of the app, and that's why you can join it.
So in a decentralized fashion, there could be other communities that build public channels in a decentralized way and announce them in some format, and they would show up as a public channel.
Yeah.
Interesting. Cool. So now I see all these DIDs. Dan, which DID are you? I guess you're all of them.
Right. So this is one thing that we should point out. So there is no public address book right now in Solarium. Maybe there will be in the future. But when you join, you just have all these relatively anonymous identities, and that's kind of nice. You don't have to give your name to use Solarium. I think that's okay. It's not really anonymous, I guess. It's pseudonymous. If somebody can find out that I am a particular DID, then you know, it's traceable. But to answer your question, the second last one there, the kind of gravatar with the green rocket pointing up, that says, "Hi everyone, just demoing Solarium." That's me.
Okay, so I think to easier identify you, I would add you as a contact in my browser-based address book.
Sounds good.
So why does this operation trigger a transaction on the chain?
Good question.
If I think I just create a reference for Dan, an alias, exactly.
Yeah, I think we will probably want to split those up in a future version. What this is actually doing when you're adding a contact is establishing a point-to-point or a direct channel between the two of us. And just like when you're connecting to the lobby, you get an encrypted copy of the key for that lobby channel. By establishing a point-to-point connection between the two of us, we're both receiving a copy of the key for this new end-to-end encrypted channel. So that's why the transaction is there. It's creating that structure on chain. Okay. So yeah, as you see now, there's a new contact, and that's me, and that means that we have a shared account, shared channel. And in fact, on chain, there's very little difference between the lobby and the channel that we've just created between the two of us, except that only you and I can and will ever be able to read the messages on the shared one. Exactly. So right now, I don't know that you've created this channel for me, so you need to tell me who you are. So if you go and post and say hello on the public lobby, I can join from my side.
Will do.
Or you can, yeah, invite me any other way you like. Okay, I've received your message. I'm going to do the same on my side. The good thing is, because that connection has already been established, I don't have to do anything on my side except add you. There we go. It's cheating if I can see what you say before you say it.
Oh no.
Right.
So what kind of services are we consuming, or is the front end consuming now to provide this service? Like I see that it's reactive, so there's some kind of WebSocket element.
That's right.
So who are we connecting to here?
That's right. So the UI itself is hosted on IPFS, and it's being pinned by Infura. It's a pure Web3 app. So the only backend services that it's connecting to is the Solana blockchain, and the Solana endpoints. The Solana API provides WebSocket connectivity for listening to accounts. So each of these channels is an account. They contain the encrypted messages. So when you're listening, when you're watching an account, as you are now, they're listening to changes in that account's data structure. And whenever the account's data structure changes, Solana sends us a notification on that WebSocket.
Cool. So could I, and this is now a question or chain specific questions, how much effort would it be to run my own Web3 interface to the Solana blockchain and not be dependent on that public production chain interface?
You mean not to be dependent on this web browser interface?
No, not being dependent on what is this Solana endpoint, Web3 endpoint
yes,
we're consuming right now?
Solana RPC API. So
Exactly.
there's a few. There are a few services that. So there's a couple of choices. There are the public ones. Then if you need more access than that, there you can. I don't remember the name of the site, but there's a company that provides bespoke ones, so like Infura, but for Solana. And of course, you can also run a validator node and expose your own.
Cool. Do we want to talk about channels versus like direct messages?
Yeah, let me give a bit of a summary. So like I said a moment ago, there's not much difference. The only difference actually is how their addresses are derived. So a group channel has an address, and that address needs to be known. So it needs to be passed to somebody in order for them to join it. A direct channel, in other words, a point-to-point channel between two participants only, is a very specific type in that its address is derived from the identities of the two participants. So these identities, these DIDs, have addresses on chain, and those addresses are concatenated and hashed in order to produce the address of the associated channel. And that allows you to discover the channel address purely from knowing the participants involved. So that was how I was able to add you, just by adding. That's how I was able to join this channel that we're talking on, just by knowing your DID and my DID.
Which will be different on general channels, because you cannot derive.
That's right. Then
channel
a channel just has an
information.
Address. Exactly. Then a channel just has an address, and you just have to know it. And you know, the public lobby is hard coded. You could also imagine having lists of known channels, and so on. A couple of things cool. I wanted to quickly mention about the. Actually, let's talk about the structure, and that'll bring us on to the things we want to add in the roadmap in the coming weeks. So all the data you alluded to this, all the data is persisted on Solana itself right now in accounts. So obviously that has a limit in the amount, in the size. What we've decided to go with is, instead of requiring what they call in Solana rent to be paid per message by the sender, the rent is paid by the creator of the channel. So the creator of the channel creates a data structure of a certain size, and that allows only 8 messages to be stored at once. And then it's stored in a circular buffer. So by writing the 9th message, sending the 9th message will erase the first message, so to speak. That keeps costs extremely low when it comes to sending messages. You only pay the transaction fee, which is very low. You don't have to pay any rent. It does obviously mean that messages, especially on busy channels, will be lost. There's no history beyond 8 and so on, although that is a flexible number. Some people like that, right? You know, lots of people that like Snapchat and so on is built around that sort of idea. But what we do want to add later on is the ability to archive information onto some long-term storage, because then it's not so interesting. It's not so important to get these quick notifications. All the work has already been done in terms of validating the senders and so on. So that information can then be stored encrypted on something like IPFS or Arweave, and that's one of the plans for later on. And that will also allow arbitrary message sizes. So right now, as you can see there in the UI, the messages are limited to 120 characters. Again, Twitter has a similar or the larger limit. It's also not a particularly bad limitation, but if we had kind of the ability to store or link to storage that was also end-to-end encrypted but stored on an offline store, decentralized offline store, then that would allow for more richer messages as well as longer ones.
Yeah, I also think that it's an advantage that the message store on chain is limited. Also, when you think about key rotations and like updating security of messages, it just means that you won't have old messages that might have been encrypted with non-rotated keys that are old and might just drop out.
That's true.
Which I feel is, from a security point, is a nice feature.
I agree. I think actually ecosystem-wise, I would always make the offline storage to be an optional feature, because obviously it would have to be paid for as well. So it would be an option that a channel creator or a channel maintainer would have rather than making it built in. And actually, when you talk about keys, that brings us on to something else on the roadmap, will be probably one of the highest things on the roadmap, which is the introduction of perfect forward secrecy. So one of the things that some other end-to-end encrypted instant messengers have that Solarium doesn't have is the use of the Signal protocol for perfect forward secrecy. So this would ensure, for example, that a message that if one message in the past was decrypted with perfect forward secrecy, that means that you can't necessarily decrypt future messages, which makes the whole thing a lot safer. And they use double ratchet algorithms for that sort of thing. That's something we want to add here. It would require offline storage that is not, well, more offline storage that's not particularly required at the moment, but I think it would be a very important security feature to bring. That would basically bring Solarium on a par with Signal and WhatsApp and the like in terms of security, while also having the benefit of being decentralized. Anyway, did you have any other things you wanted to talk about, Martin? Any other questions? Otherwise, I think we can probably leave it at that. We've seen the important bits.
Yeah, I think the last question I would have is around the keys used for signing transactions and key used for encrypting messages and decrypting messages. So we use different keys for that.
That's right. We actually use the same
for that.
We use the same curve, but we use different keys. Yeah, thanks for reminding me of that. It's an important point. As you can see, or as you heard, Martin was signing transactions while he was going through onboarding, and that signing is happening through the integration with the Solid web wallet, and the interface standard interface to wallets on most blockchains is limited to signing. In some, you can encrypt arbitrary messages as well, but you don't ever have access to the private key itself. So often you can't, and on Solana, you can't encrypt a message, an arbitrary message. So each device that is connected to an identity has its own key, and we call it the decryption key. And that's used purely for encrypting and decrypting messages, or rather specifically for encrypting and decrypting the content encryption key that then encrypts and decrypts messages. And that's separate from the key to sign. So that key to sign is the one that would contain your funds. It's the one that should be kept the most secure. And then the decryption key can differ from device to device. And then the thing that is important is, how does the blockchain know that the person who encrypted the message is the same as the person who sent it? And that's where the on-chain identities come in. So you can always check that the signer is the right, is a member of the, you can check that the signer is a member of the channel, and that the decryption key has the power to decrypt the channel, so to speak.
Yeah, and I think that's some of the advantages also of the DID abstraction, that even though I have one identity, I can have multiple encryption / decryption keys associated with that are device specific.
Yeah.
And if someone chats to me, it transparently encrypts the channel specific key for all of these devices. And I can read the messages on all of the devices.
Exactly.
Which is pretty nice.
Right. So I think that's it, Martin. That's I think everything we wanted to cover. Thanks very much for joining me today and for working with me on this.
Yeah, thank you so much. I mean, it was a really nice hackathon. I really enjoyed it, and the all end-to-end aspect from blockchain to React. I really enjoyed it. Thanks for that.
Yeah, me too.
I will write you one last message in Solarium. Oh. Hackathon. I think that's how you write it. Bye, Dan.
Bye-bye, Martin. Thank you.